Okay, so to get the derivative of this one, the first thing we're going to do is we're going to rewrite it as the square roots. We're going to rewrite them as exponents. So we're going to rewrite this as, so this big parentheses is going to be the most outside root. This is going to be to the 1/2. And so we're going to have inside of here 5x plus, and then instead of this root, we're going to write to the 1/2. And then inside of here we have 3x squared plus e. And here, instead of raising, since we only have one term in here, instead of writing e to the x to the 1/2, we're just going to write it as e to the x over 2. And this will make it a little bit simpler for us. Okay, so then the derivative of this guy is going to be, let me rewrite this. Okay, so first we take a look at the most outside function, which is this whole thing that's being raised to the 1/2. And so we use the chain rule here. So we're going to bring down the exponent. So we're going to have 1/2. And then remember, you leave the inside alone. So the inside we're going to leave alone. Everything is the same. And we're going to subtract 1, so we're going to have minus 1/2. Okay, and then we go in one level, and so we multiply by the derivative of the inside. So the inside is this blue that I'm highlighting right here. So the derivative of that is going to be the derivative of 5x, which is 5, plus, and then here we have another chain rule. And so here, the derivative of this, we'll have to use the chain rule again. So I have to bring the 1/2 down, leave the inside alone, subtract 1, and then times the derivative of the inside. And the derivative of the inside, which is this guy, is going to be, so this is a tight squeeze, but the derivative of this guy is 6x plus e. So here again I have to use the chain rule, so it's e to the x over 2, because the derivative of the exponential function is just itself, times the derivative of the inside of that, the derivative of the inside, the derivative of x over 2 is going to be 1/2. And that's it. And here I don't have room to close the parentheses, but that's where it would close off. Okay, so to do this problem, we have to use the chain rule multiple times. The first thing, you realize that the outside function is cotangent. And the derivative of cotangent is negative cosecant squared. So we get the derivative of that, and then remember that we leave the inside alone. So the inside, we don't even touch it. We just leave it exactly how it was. Okay, and then we move in one level, and find the derivative of this. Well, here we have to use, since we have a product of e to the x cosecant x times sine of x squared, we have to use the product rule. And so here we're going to get the derivative of the first, which in and of itself is a chain rule. So we have the derivative of e to the x cosecant x. So that's itself times the derivative of its inside. So times the derivative of the inside of the exponential function, which in and of itself is another product rule. So inside of the derivative of this one, using the product rule would be the derivative of the first, which is x, so that's 1 times the second, leaving it alone, plus the first times the derivative of the second. And remember that the derivative of cosecant squared is negative cosecant x cotangent x. Okay. Now that's just the derivative of this first part of the product rule of the green one. Okay, and then you multiply that times the second, leaving it alone. And then plus so we're going to continue over here. This is the continuation. Plus the first, leaving it alone, e to the x cosecant x, times the derivative of the second, which is cosine of x squared, times the derivative of the inside, which is 2x. Okay, so that was pretty intense. So let's go back a little bit and revisit. So here, all of this green that you see here, all the green writing, this is the product rule inside of here. And so what this is this is the derivative of the first times the second, leaving it alone, plus the first, leaving it alone, times the derivative of the second. And that's the product rule, right? And now that's it. We're done. So this should all be on one line. And also, so note that here, when we did this little blue section, that was because of the chain rule. We had to do the product rule up here. So this is the derivative of the first times the second, leaving it alone, plus the first, leaving it alone, times the derivative of the second. And that's where that comes from.